Okay, so good to go. Let's talk Python. All right, so let's think back to last time, just quickly review. We did not get super far conceptually, although I think we did, so we didn't cover a whole lot of different things, but we've got good depth on what we can cover, which is hopefully useful for those of you that are like total programming novices. Maybe a little slow for those who have done some stuff before, but I think we'll pick up more and more as these things get more solid. So hopefully everyone that's got something with them today has Python on it and can follow along. If you're having any trouble getting Python on your stuff, we can talk more about that afterwards. Oops, Python. But I'm just going to keep doing my Python for now in the command line here. I think that we can just do that for today. Probably next time onward, I'll bring some fancier stuff into the mix. But right now, I think we can just think about Python still just entering commands right into this, what we call the interpreter, right? Rather than making a whole file full of code and having it run that file all at once, okay? So if you remember last time we talked about variables, we talked about how there can be different types of variables. We talked a little bit about how you can like make variables in Python. So if I wanted to make a variable and call it, let's say, cookies, that indicates how many cookies we're going to order for today, and I want to give it the value 18, so that the number of cookies is 18, how would I type that into Python here?
Cookies equal 18.
Yes, indeed. Right, so that just does that. Now, if I want to see the value of cookies, I just have to take it on faith right now that that happened, right? But if I want to see what value the name cookies has, how could I get that?
Type cookies.
Okay, so I could just type cookies, or I could say print cookies, right? Which, like, in a script, I'd have to say print cookies. But if I'm just typing it on the command line, it's sort of implicit that I want to see the value of the variable. Okay, so that lets me do that. Now, we kind of had alluded briefly, I think, to this idea. So let's say we're going to divide our cookies among like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. So if we want to figure out how many cookies each of us gets, we could say cookies divided by 11, right? But this claims that we only get one cookie apiece then. And we had sort of briefly alluded to what that might mean. What does it look like is happening? So let's actually try a couple different things. I've primed myself now for wanting cookies. So if we try to divide among 11 people, it says one cookie. If we try to divide among, let's do 10 people, well, that's still one cookie, right? Now, if we try to do among 9 people, that'll give us the right answer, which is 2, right? But if we then do, like, divided among 8 people, I'm just hitting up, remember, to get the previous command, which is a nice little trick. Then I can edit it. All right, so that still says 2. So what's it doing when we divide cookies by some number?
Round up.
Right, it doesn't round.
We need to do a point.
You need to do a what?
We have to do 8.0 divided by
Okay,
8 or something.
so this doesn't work right, but if we did do this,
Yeah, that.
it does work, right? And I think we didn't really get into that too much at the end of this is kind of where we left the mystery last time, if I recall correctly.
I have a question.
Yep.
If you created another variable for people, and you had like 2 variables divided by 1, would that still equal? Would that fix the problem, or is that still like only give you 1 digit?
Well, let's see. All right, good. I mean, again, this is all like basic in one sense, but these are good like problem-solving strategies to be thinking about. Because like one of the things that'll help you most in programming is like just kind of try and if you're not sure how something's going to work. I was just listening to a nerd podcast about this the other day, where a guy was saying like, he's been programming 20 years, and you'll hear like the junior programmers at his job like arguing about like what the language does or something, and he's just like, guys, you can just type code in the terminal for like 10 seconds and just get the answer. Like you don't have to hypothesize about what it would do. So we can do that. Good. So that doesn't solve the problem. Now, if we had said another way, that, and then do cookies over people, now we get the right fractional answer again, right? So clearly, in some cases, it's truncating the fractional part of the answer and just taking it off. In other cases, it is properly giving us the full fractional answer. What's the distinction between those cases?
You only have to define one variable by a decimal place, so I thought you'd have to do both of them at first, but it looks like you only need one.
Right. So only one of these two things. Right. So I won't bother to redefine a new variable, but if instead we said like, 18.0 cookies divided by 8 people, that's fine too. That gives us a fractional answer too. Okay. So I'll tell you the answer to this, which is, so previously we had talked about numeric variables, and the other thing we had is string variables, right? So, like cookie source equals, the cookie company, or whatever they're called, right? So we could have a string like that, and we could say print cookie, oops, oh, this doesn't work in this one. Okay, cookie source, and it'll print it out, right? So we talked about numeric variables, we talked about string variables, which have text in them. But numeric variables can be divided up into two types, one of which is integers, right? So like 8 and 18 and all those are integers. But if you want a non-integer data type, which in programming parlance, you'll see it referred to as a floating point data type, you need to explicitly say that, okay? So like what Python does, and this is sort of a weird quirk of Python, as I think we briefly alluded to before, like some other programming languages like C don't work quite this way. Like if we instead wanted to say like we had 8 cookies in C, this won't work in Python, but I'll tell you how we would do it. We'd say something like int cookies equals 8. Now, this is not going to work because it doesn't know what the word int means in Python, but in a language like C, what you actually do is when you create a variable, you actually tell C, the language, like what type of variable it is, whether it's an integer or a string or whatever. In Python, it tries to infer what kind of data you're putting in a variable. But the way it does that is, or at least the way it does that with numbers, is if you don't have any decimal places in the number, it assumes it's an integer, right? So, this is not an issue for things that are already expressed as floating point, right? So if we said like cookies per person equals 2.25 or something like that, right? And we said print cookies per person, like that's fine. And if we said cookies per person times 8, we get 18.0, right? So like that all works fine. But the weird case is where if you have something like 8 people and 18 cookies or whatever it is, but you still want to be able to get a fractional answer with math that you do with those, you need to actually make at least one of them be this floating point kind of variable, or this floating point kind of number, right? So this works even if you just directly put the numbers in, right? So 18 divided by 8 is 2, 18.0 divided by 8 is 2.25, 18 divided by 8.0 is 2.25. Does that make sense? And of course, if you do put... Excellent question. Here's why. This is more, I won't do the most technical version of this. But let's say, all right, let's say it this way. So what's actually happening when you put this information into a variable, right, is it's setting aside some memory in the computer, some number of bytes to represent that information, right? So another way to think of these variables, there's all these metaphors you can use to think about what the computer is doing. Another way to think of it is like you have a fixed number of sheets of paper, and each sheet of paper can have a certain amount of information on it and a name for that sheet of paper, right? So you can kind of think of it like a filing cabinet, right? So on the sheet of paper that you've labeled cookies and filed away in your filing cabinet under cookies, you can put like one number, which is 8 or 18 or something like that, right? and that those are maybe filed by type of information also, right? But, your memory is limited, right? Less limited than it used to be. Now we've got like gigabytes and gigabytes of memory, but still not an infinite amount. So you want to use it efficiently. So let's say you set aside like 4 bytes of memory in your computer, which is 32 bits, to represent a number, right? Now you can think of this by analogy as saying like, so bits and bytes are just like binary digits, right? So it's numbers in the binary system, but we can think of them in like decimal terms, right? So let's say I only give you like 5 regular decimal digits to represent a number that you want to represent, right? So if I just say, all right, you have 5 digit places to represent whatever number you want to represent. You can represent 0 through 99, like 00000 through 99999, right? If you want to represent an integer. Now, what if you only have those same 5 digits and you want to represent something that's not an integer? What would you, okay, so I'm going to allow you like one other symbol, say, or 1 or 2 other symbols that aren't the decimals themselves or the numbers themselves. What would you do to represent like a decimal type value? Like just when you write it, not in the computer, but just like if you write, if you have 5 like physical digits, like obviously you can use those to represent 0 through 99999 like integer wise, but you could also add what to make it a fractional value? A what?
Like 10 to the second.
Well, okay, we were jumping ahead, but you could add a decimal point first of all, right? So you could, if you just add a decimal point to those 5 digits, you could have like 9999.9 or 7234.6 or 7.3461, however many digits I said, right? So you could like put a decimal point at some place in those 5 digits, and that would let you represent something from, I guess, 0.00001 up through, 9999.9, right? Like if you get to put that decimal place anywhere in there. But that doesn't give you a very large expressive range of values, right? So now jumping to where you guys jumped ahead, let's say you added one other thing that you could throw into that representation, which is what? Exponents, right? So you could put that in scientific notation instead, right? So you could like put a decimal point and put some numbers after the decimal point, but then use some of your allocated 5 digits for the exponent, right? So you could have like 3.24 times 10 to the 29th or something like that. Or, have you guys ever written, let's put this out here, like, this is not going to be Python code, but it'll just be text. Like, sometimes you see scientific notation numbers written as like 3.29 E14 or something like that. Probably your like calculator or something like that uses that kind of notation. So that uses only 5 numeric digits, right? Which was kind of the rule I imposed upon us. But it expresses a much larger value than you could express with 5 digits, right? It expresses something that with like 14 zeros after it, right? Which is more than you could. Now it doesn't express that very precisely, right? It only lets us go 2 digits after the decimal point with that, 10 to the 14th scale number. But it does let us express it some way, right? So what floating point means is basically like you have the kind of binary equivalent of a decimal point and an exponent in that number, and the point is allowed to float around. So like you're allowed to use your kind of binary digits and move the decimal point and the exponent around, so that decimal point gets to kind of float between like where in the number it falls. So you are trading off essentially, right? Because you have a certain number of digits to spend on your exponent, and you have a certain number of digits to spend on your like non-exponent part of the number, right? So you're trading off basically like the magnitude of the number you can represent with the precision that you can represent it at that magnitude. Does that make sense to people, or is that like totally crazy, confusing? Okay, so that's why it's a floating point, basically, is because the decimal point gets to move around and the exponent gets to adjust to, in order to like use the same number of digits to express them. Okay.
The reason we only need to do one variable as a float and not both of them is because like the program or whatever knows like, well, they have a float in the math they're doing, so I'm assuming their output they want to float.
Exactly. So that's Python making. So that's nothing about like intrinsically how the computer works. That's something about like Python's grammar essentially, or Python syntax, where Python's sort of heuristic is okay, if you give me two integers and ask me to do math on them, I'm going to do integer only math, right? But if you give me some math to do, and one of the things is a non-integer, then I'm assuming you want me to do non-integer math throughout. Yeah. So that is the whole yeah. So I will the integer versus floating point distinction is something like very deep about the computer because basically the way CPUs work, like there are different ways you do calculations on floating point versus integer numbers, and like integers are way faster. So like way easier to do math on integers and floating points. So like it's in almost every programming language you want to make that distinction between integers and non-integer numbers, just because like it's way more efficient. But yeah, this like convention where one thing is a floating point number and one is not, that's just like how Python chooses to interpret what you mean when you don't explicitly say like what kind of value you want. Yeah.
So when you're writing code and you're not sure if your variable you want it to be an integer or floating point, which one is the default when you're writing?
Well, so the default is however you express the first value you give it.
I mean, like, what do you want to default to?
Oh,
Like when you're writing it, should you make it an integer? Or
well, it depends on what you want to do, right? Like, I mean, technically, if you only ever need the values to be integers, your code will be a little, I mean, probably none of the code any of us are ever going to write in here is going to, like, really matter how efficient it is, because, like, it really matters if you're, like, doing a game and you need it to, like, render at 60 FPS and you're doing all these crazy calculations to make that happen at sufficient resolution. Like, with what we're doing, like, everything we're going to execute is pretty much going to go instantly because, like, we're going to write simpler code. But, I mean, if you don't need it to not be an integer, may as well just leave it integers because that makes life less complicated. But, you know, if you think it's possible that you'll need decimal representations, you can use floating point, yeah. And it depends, again, this will depend on the language. Like if you start using MATLAB by default uses floating point for everything because it is assumed that most of the time in MATLAB you're working with scientific data. Scientific data is like rarely clean, so it, you know, like you often want the most exact answer you can get instead of this like weird truncated integer answer. So like in other languages it may default to floating point, but in Python, you know, if you get to choose, you may as well choose integer if you're sure that you're only ever going to need integers, right? Okay. There's one other point I think I wanted to make. This is probably more than you ever wanted to know about how numbers are represented in Python, but that's okay. Where do we get to with integer? Oh, I was going to try one other thing. So I think if you remember, we tried something like this before. So if we tried something like 4 times 3 plus 2 in Python, I can put a space in, it doesn't really matter. All right, what answer is that going to give me? Should give us 20 because every programming language I know of follows the order of operations that you know from like algebra class where you do parentheses, PEMDAS, right? Please excuse my dear Aunt Sally or whatever. Parentheses, then exponents, then multiplication, division, then addition and subtraction, where multiplication and division tie for priority, and so do addition and subtraction, and you go left to right if there's a tie, right? Okay. Now let's try something like this. Let's just change the plus to a divide. This will work just fine. What answer is that going to give me?
4.
Okay. Correct. Now the real question is, what is that going to give me?
4.
All right. You would think the answer might be 6 based on what I've told you, but it actually is 4. Now what is this? What can we infer? Well, it's 4.0 to be precise. So you notice Python represents 4 and 4.0 differently, right? So it's telling us that this is exactly, well, it's telling us that it's 4, but it's 4 as a floating point number, right? Not as an integer.
Is 2
So why is it doing
and
this?
3 doesn't round up anymore, it rounds down to 1, and 4 times 1 is 1.
Okay, right. So what we can see here is that Python doesn't do that whole like trying to figure out what you mean by this thing any sooner than it has to, right? So like each individual step of this process kind of follows the individual rules, right? So like 3/2 by itself would be 1, right? Because Python sees 2 integers, says, all right, we're doing integer math 3 divided by 2 is 1 with some remainder, so I'm just going to give you 1 because that's how I deal with integer math. And then it multiplies that by 4.0, but at that point it's just a 1, right? Does that make sense to everybody? So the reason we kind of are spending a little time on this is like, when we get to more complex programs, this is something I really want to stress this semester. Like, people tend to like look at programs kind of like you're looking at like sentences or like paragraphs or something, and like think about kind of the global meaning of it. But what the computer is really doing is like taking every little phrase and processing. Like when you read a sentence of English, you're reading like left to right, but you can like skip around. If there's a word missing, you can kind of like read around for context and like figure out what else is going on, right? Like you can kind of have this higher level sense of organization about what's going on when you read sentences, right? You don't just like process each word in sequence and get immediately confused if something's not there. But the computer is like that, right? It can only go kind of in a set order depending on how you write stuff. So in this case, let's get my cursor over here. Cursor. Where are you, cursor? There you are. So in this case, like, all right, this is not going to show up. You know, here, it's going to do, because the parentheses do mean like do this first, it's going to do that first. It's not like looking ahead to do the second thing next, right, until it's done with the first thing. So it's going to go like bing, bang, boom through the steps you have told it to do. It's not trying to extract any like higher order structure or understanding from what you're typing, right? So like that's going to be super important to keep in mind later. Okay.
So this is an easy way to mess up your programs, like not paying attention to like what is, because it seems like easy way to mess something up. Like I feel like when I type, like I don't think about floats. I think about.
This is so. This is one easy. I mean, like there are fine points to this that get really dicey. So one issue is like, you know, with floating point math is intrinsic. So integers are like, one reason integers are nice and easy is they are precise, right? Like you can do integer division and end up with a non-integer number, but if you just chuck away the like fractional part, like integers, if you agree ahead of time that like everything's an integer, like you can be very precise about the number that you have, but only within a certain range, right? So if I tell you like, you can write any integer you want, but you only have 5 like decimal digits to write it in, there is zero ambiguity about what number you have written, right? You just can't exceed that range. You know what I mean? Like you can't write any number smaller than 0, and you can't write any number larger than 99999 if I tell you like integers only 5 digits. But I give you 5 digits and I say like express a decimal number of arbitrary size and precision, and then like I give you a number to try to represent with those 5 digits, you're going to take the best shot you can, right? Like you're going to say, like you can express a huge range of numbers, but you have to trade off between like representing the magnitude correctly and how many digits of precision you give the non-exponent part. Does that make sense to everybody? So like, you may remember this from like chemistry class or whatever, where you talk about significant digits, right? Like here, your number of significant digits in a floating point number are limited by just like the intrinsic limitations of how many bytes are allocated to that type of data. So anyway, the issue is like sometimes floating point, you can't tell if two numbers are exactly equal because like through some chain of mathematics, they may have gotten off by like 0.00000000001. And if you try to like compare and see if they're equal, the computer will say like, nope, not equal. They're technically different, even though they're within like 10 to the minus 15th of each other. So anyway, there's all those issues, yes. But yes, this is an easy way to get bugs if you're not thinking about this stuff. If you can keep in mind though, when you're in integer world, when you're in floating point world, it's all right. Okay, so one other thing, what were we on with this? Integers, floating points. Oh, that killed my, sorry. Good question, but that, now I've forgotten where I was gonna go with that. Okay, well, I'll find it again. All right, so let's talk about now like some other stuff you can do. So this is pretty boring, what we're doing now, right? So let's say, I think I lied to you. I think I actually am going to start writing some real code today. So let's actually do it this way. I don't think I have any old code up here. All right, so I'm going to, you can use whatever code editor you want. I'm going to use Visual Studio Code, which is a nice free thing from Microsoft, which I actually kind of like the format of. I'm just going to put this in, let's just make a folder called like Python, whoops, Python Beginners. All right, so let's call it like example01.py or something like that. All right. And nicely, Visual Studio Code knows that I'm writing Python code because I gave it a .py extension, so that's going to make life kind of nice and easy. Because it'll, so what code editor will do, it'll like highlight important information in color, right? So I can just type something like, cookies equals 18. I don't know if you can tell this on here. Company equals the cookie company. So you see, like, I'm not doing anything to format this text. This may be like super obvious if you've done any coding before, but if not, I'm just writing straight text. But Visual Studio Code, my editor, is doing me the nice job of like highlighting, like kind of parsing ahead for me and telling me in Python syntax, like it's going to highlight the numbers, the strings. It'll put different parts of the language in different kind of formatting for me. Although this is still just a straight text file, right? So if I go back to my terminal, I'm going to exit out of my Python interpreter, right? So I'm now just back in like the regular command line. If you are not a Unix person, don't freak out. I'm just going to go into, oops, where did I put that document? Oh, Python Beginners, right? Not beginning Python. Yeah. Okay, thank you. All right. So I just did a file listing and showed, like, there's the file that I have. I'm going to use the cat command, which doesn't do anything about cats, but it shows you the contents of a file. Like, that's just a straight text file, like .txt basically, that has that text in it, right? And so Visual Studio Code is doing the highlighting for me, but that's not part of the file, right? Visual Studio Code is just like looking at it for me and kind of temporarily giving me that highlighting to help me out. All right, so let's try something here. So let's switch back to the terminal and actually try this in script mode. And we're going to say Python example01.py. And it does absolutely nothing, or it appears to. Why did it not do anything? Right, I didn't really tell it to do anything, right? I told it to like assign some values to some names, but I didn't do anything with that. Now, I could do that with something like, I got some cookies. Yay. I saved that there. You couldn't really see it, but I hit save. Do that now. It says, I got some cookies, right? So that's the like active part of the code. But the other stuff happened. It just didn't like do. It didn't tell the computer like do anything to show you, right? So you could say something like, print. I got. Let's see if this works. Cookies. Cookies. All right. I'll save that and see if I remember my Python syntax correctly. I got 18 cookies. Yay. Oh, wait, and it even did it.
You got 2 spaces.
Yeah, I did it righter than I thought. I was thinking about how MATLAB does this. It automatically puts a space in for you, so I actually didn't need to put that like space in after I got. Just a nice little thing Python does. I got 18 cookies. So what is it doing there? What does that let us infer about print that we did not know before about the print statement?
It can print variables.
Okay, it can print variables. I think we did that somewhat before, but it can print variables, especially what? Like
in strings.
Yeah, so you can intermix variables and strings as long as you separate them with commas, right? And there's a few actual different ways you can do stuff with print that we're probably not going to get into. But let's try a couple other things. So what will that do if we run that one with Python? Yay. All right, cool. So that totally works, right? Now, just to confirm, what is that going to print at the end of this program?
18.
Correct. So it says 18 there. Now, why does it not say 21 at the end?
Didn't add anything to it, still the same variable.
Right. We didn't tell it to change cookies, right? We temporarily added 3 to it for the purposes of printing, but we didn't save that cookies plus 3 anywhere. Does that make sense to people? So keep in mind that like when Python sees, cookies, it just substitutes in the value of cookies. So it'll print 21 there, but until you say cookies equals something else, it's not going to change the value that's inside that name cookies, right? All right, excellent. One other thing I was going to do with that. Oh, well, this is pretty easy, but we'll do it anyway. So we can take this part out, that doesn't matter. Let's see. Oops. From. All right, so what's this going to print out? No, hopefully it'll work. Yay! All right. So that shows us that we can do this with like strings too, right? Not just numbers. So anyway, yeah, basically we can do print and then a bunch of things separated with commas, and it'll print all this stuff in each thing, whether it's a literal string like I got or cookies from, or a variable representing a number like cookies, or a variable representing some text like company. Okay. Now, we didn't explicitly ever do this before, I don't think. What is this going to print? Or what is it? Is this going to work at all? What is this going to do?
It'll
It'll-
change.
It can add 21. So I think I've basically within SAS, like I know if you define a variable and then add by itself, it's still like it replaces it. I don't know if that's the same with Python.
So is it 18? It's 18 right now.
Well, all right. So this is a good point where it's good to start. Oh, this is what I was going to say earlier. The same podcast that I was listening to, different episode. The guy used a phrase that is really great, which he's called empathy for the machine, which is this idea that like, yeah, we got to start thinking not like us, but like the computer, and not kind of like looking at this thing like a human does and kind of getting the broad sense of it, really thinking about what would happen if you executed this code line by line in order the way the computer does. So yeah, if you're doing the computer thing, you can barely see the line numbers here. Sorry, 1, 2, 3, 4, 5, 6, right, are the numbers of the lines. You can see it better down here, actually, what I've got selected. So if the computer is executing that first line of code, so it sees cookies equals 18, it says, all right, I'm going to create like a chunk of memory called cookies. I'm going to assign that the value 18. This, it'll like put that string information in the variable called company. Here it will print out, I got some cookies. Then it'll go to the next line. It's blank. It doesn't do anything. All right, so when it gets to this line, what does it do? Or what do we think this would do?
It'll turn it into 21, and then it'll be 21, not 21.
Okay, so that is correct. Let's see it do it. I got 21 cookies from Cookie Company. All right, right. So what is it going to do if we took this and put it here instead?
Then also you got 18 cookies.
But it'll still be changed to
Okay.
21.
All right, very good, right? So it says 18. Yeah, it would be changing the value of cookies. So, if I just print cookies after this, it'll then say 21, right? So is this clear to everybody what's going on here? So this is like basic stuff, but it is just like you were typing all this stuff into the command line one line at a time, right? So it like reads the first line, does the thing. Reads the second line, does the thing. Reads the third line, does the thing, right? Like it's not looking ahead to see what you're planning on doing later. So if you try to use something before you define it, it's going to be like, what? I don't know what, even if you like write it right after that, like it's going from top to bottom, straight down. It can't look ahead. Not like a person can, right? Yeah, so it's just going straight through. Okay. Now there is an exception to going straight through. And we only have a few minutes left. So I'm going to just write some stuff and we'll start to deconstruct it a little bit. And then we'll pick up on this next time maybe. So Okay. Now let's try something. I'm just making this. This is a very boring dialogue, but I'm just going to make this up as we go along. All right. So while it's going to bring in a lot of stuff here. We don't have to unpack it all at once. Oops. I have to put quotes in, or it will freak out. Cookie, cookies equals cookies minus 1. Now, is that in PW? Now I have cookies, all right, so I do, unless you have programmed a fair bit before, no more cookies, all right. So let's just run this and see if I did this right, and then we'll talk about what it did and why. Okay, should have started with less cookies, because I'm off my screen now. All right, so I got some cookies. Got 18 cookies from the cookie company. 21. Got 3 more cookies. I'm going to eat cookies now. I'm eating a cookie. Now I have 20 cookies. I'm eating a cookie. Now I have 19 cookies. Blah, blah, blah. I'm eating a cookie. Now I have 0 cookies. Now I have no more cookies. Okay, so I did exactly what I thought I was going to do. Now the question is, this is all hopefully new stuff to some of you after like line, what is that? After line 8. So starting at line 10, well, line 10 we know it's just going to print that stuff, right? So let's start to figure out, or start to just think a little tiny bit about what happened in line 11 onwards, and we can pick up here next time. So what does it look like, just in like loosely speaking language, somebody that doesn't know this much of this stuff and is actually kind of figuring this out, answer this question. What does it look like this is kind of doing?
It kept looping it, but I don't know how it knew to loop it, I guess, because, I mean, what you did made sense. Like you said, wow, like you have positive number of cookies, you keep subtracting 1, but I don't know how it knew to loop it until you had 0.
Okay, good intuitions. Anybody who's like just learning got anything to add to that?
Will it go back to while as long as it's true? And then when it stops being true, it keeps going?
Okay, yeah, these are all correct, good intuitions, right? So there's a lot of stuff here that we haven't really talked about, right? So the print statements should make some sense. We didn't really talk about the greater than thing, but you can probably guess what that means, right? So cookies greater than 0. Well, I mean, we can test that out if we go to like the actual Python thing here, right? So if I actually start typing Python commands in here, if I type 5 greater than 4, that's going to tell me true. 5 greater than 6, that is false. What about 5 greater than 5?
False.
False. 5 greater than equal, oops, not equal, greater than. 5 greater than equal 5. All right, so these, now what is this going to do? This is actually maybe an important thing to end on before we even get to what that while means. What is that going to do? All right, why does that not work? Well, that doesn't work because how have we seen the equal sign before? Like that, right? So equal means something different in the Python than it does in the real world, right? So anybody, well, people that have programmed before know this. People that don't program have no way of guessing. So we want to see if something is equal, we have to use 2 equal signs. So double equals. 5 equals 5 is true. 5 equals 6 is false. So if we said, how many cookies do we have in this example? 5. So does this make sense now? I forgot to like harp on this. All right, so how many cookies does that variable represent now? 6, right? Because we said cookies equals cookies plus 1. This is something that now, if we did it with 2 equal signs, what's that going to do?
False.
Correct. How many cookies do we have right now? How many? 6. But we don't have 7, right? Because we can enter this as many times as we want, and we're not changing the value of cookies, right? So let's wrap up now because it's 2:59. But basically, the thing I've realized that looks kind of weird to people that are used to algebra and not programming is a line like cookies equals cookies plus 1. If this were algebra, that is an impossible statement, right? Like you couldn't solve the equation x equals x plus 1 because there are no numbers that are equal to themselves plus 1, right? So what you're doing here is like where the difference in equals between math and programming becomes apparent, right? What you're really doing here is first evaluating cookies plus 1, and then you're assigning that to be the new value of cookies, right? So first you like just do the expression cookies plus 1. You say, all right, cookies is 5, add to 1, that's 6. And then the last thing I do is store that in whatever's over here. So I could, say something like more. So if I do this, we'll wrap up in just a second. Cookies. All right, now what is in cookies?
Still 6.
Okay, still 6. What is in more cookies?
7.
Well, it depends. It's a variable in there. So if you change cookies, you change more cookies.
Oh, that's an interesting. All right, so let's wait a minute. All right, you guys are thinking of things that I would have never even thought of because I've been doing this too long. All right, so right now cookies is 6 and more cookies is 7. What if I say cookies is 9? What is more cookies now?
Well, since
I
it's
don't
the
think
order,
so.
yeah, the order of operation or not operations.
Still just 7. All right, so this is an important, I would have never even thought about this because I've been doing this way too long, but this is like how humans think and not how the computers think. Right, so when you say more cookies equals cookies plus 1, that's another example of like that's an equation that's not like an equation from algebra class that is like x equals y plus 6. Like that's a line, right? That's a statement that's true for all time and like has a range of possible values. This is just saying do this one time. This is like a one-time command. Once it's done, like Python forgets that this ever like the program has no memory of its previous commands, and that's like another thing about how this is different than like. I think I might have said this last semester. Like it just lives in the moment, man. Like it's not like us thinking about the past and the future, right? Like whatever line of code it's on, whatever state it's in right now, like that's all it knows. It knows like what variables, like what's in memory right now. It knows like what it's stored on all these little like pieces of paper it's written down. What it's being told to do, like it's like Dory from Finding Nemo, right? It can only like hold on to like one thing at a time. And just then whatever else it can like see right around it, right? Like it doesn't recall what you told it to do before, right? So that's a really good point, yeah. And that drives home the idea that this is not like an algebraic equation. This is just saying this one time, figure out like what 6 plus 1 is, which is 7, and set that equal to more cookies. Or set more cookies equal to that more precisely. But then if you change what the original cookies value is, that's like, okay, the example is like the sheets of paper, right? Like, it's kind of like that Sally Ann task that people do with, which actually involves cookies, I think, that they do with like kids to see how their theory of mind works. Although it's a bit more like the version that works on kids with autism, which is the photograph test, where like, you guys know the Sally Ann test where you like tell a kid like, oh, Sally has this cookie, and then she like hides it somewhere, and then I forget how this works. Like Ann comes along and moves it, and then Sally comes back, and where does she look for the cookie or whatever, right? The version that, kids with autism can't do that very well, but the version that works with kids with autism, which is weird, is like, I took a picture of this room, then I moved the couch. Now I've developed the picture. Like, what do you see in the picture? And the kids with autism, it's the same like logical task, but the kids with autism can do the photograph task when it's not about people in mind states, but they can't do the task very well when it's about people in mind states, which is weird. But anyway, so this is like that, right? So if I had all these sheets of paper and I said to you, like, write on this paper 6. Now write on this paper, like, whatever's on that paper plus 1. You write like 7 on this piece of paper. Then you take the other piece of paper and erase it and write some other number on it. Like it doesn't change the piece of paper, you know what I mean? Like the instruction that you once referred to this piece of paper to write on that paper doesn't affect like the future history of those pieces of paper, which like is an excellent distinction to make. And like kind of the point of this whole like equals does not mean the same thing as in programming as it does in real life thing. Okay, the only last thing I will point out, if this blows your mind a little, don't worry about it, is this is kind of just following order of operations the same way that our multiplication and division did, right? So the only difference is, well, let's not think about this too hard, but this is basically just an expression where the equal sign has like the lowest priority. So everything else gets done before the equal sign, right? So like everything to the right gets done, and then it does, so it would be like PEMDAS equal sign would be like the way this kind of works, right? It's like you do all the stuff to the right of the equal sign, and the last thing you do is set the result of all that stuff that happens on the right, you know, and take that in, put that into the variable that stands on the left. Now, the reason I don't want you to think too hard about that is because you can do stuff like, let's see if I can do this right. Let's see if I can even do this right. It's unwise of me to even be showing you this if it works. More cookies equals 6. Oh, okay, no, it doesn't. It doesn't let, okay. This is actually good for me to learn. Python is smart. It doesn't let you do dumb stuff like this. Other programming languages will let you do this. So the difference in Python is like equals not only has the lowest priority, but you can't like, let's try this. Like cookies equals more cookies equals 5. I don't think that'll work. Oh, that does work.
It didn't print anything.
Well, that's okay, but that's interesting.
They're just saying they're all equal.
But this is, oh, you know what? Let's see if this works. Now I'm rabbit hole. Okay, that doesn't work.
What if you did cookies equal?
This is interesting, though.
Equals checks for it.
I know, so he just said equal.
Yeah. Well, what I was trying to do here is, I mean, maybe you saw what I was trying to do. In some languages, when you say like more cookies equals 6, that does return a value, which is whatever value you assign to the variable. And then you could do 6 plus 1 to that and put that in lots of cookies. But Python doesn't let you do that. It clearly, I guess, lets you set two things to be equal to each other and the number at the same time. Because if I do print cookies, and I do print more cookies, that'll both work. But it actually doesn't let you do expressions with that stuff. All right, so if that's confusing, forget everything we just said here. You will, in your real life, you will never use the single equal sign, except as like variable equals and then some expression to calculate or express the value that that variable wants to have. If you have single equal sign in the middle of a line somewhere, that means you screwed up and you meant to have a double equal sign. Like you can pretty much take that as forever true. The weird cases where you might have equal in the middle of the line are for like if you are some crazy person writing a game in the 80s in C. So don't worry about that unless you have a time machine. All right.
Can you do like cookies equals more cookies equals more cookies plus 3?
You guys are,
I'm just curious.
equals more. That's a good question. I think this will work. Let's see.
Can
All right.
you test it now?
All right. So actually, what are the values in these things going to be now? What's going to be in cookies and what's going to be in more cookies?
Does
It should be 5.
does equals resolve leftmost first or rightmost first?
They should all be.
Oh, these are all good questions, actually. I'm not sure.
We print.
I think, all right, I think I know my hypothesis is that they're all 8, or they're both 8. All right, I'm right. The reason is, the other weird thing about the equal sign, it's not only super low priority, but it evaluates right to left, unlike every other operator. So, like, in this case, like, in other words, if you have like 5 times 4 divided by, oh, this is a good example actually. All right, so many things. All right, so 5 times 4 divided by 3, what is that going to give us in Python weird integer math?
5.
It's not going to give us 5. It's going to give us, I think.
Oh, wait.
Well, how do we know what the order of options is? Right to left?
Oh, wait a second.
Be 6, right?
Well, that's the question, right? Should be 6. because multiplication and division tie for priority, and it does left to right then, right? So there's 5 times 4, which is 20, divided by 3, which is 6 point something, and it drops the point something, instead of doing 4 divided by 3 first, right? So yeah, so equal signs are weird in that they do the rightmost things first. So, and this is, again, this is like stuff will never have to worry about in real life. I'm sorry I ever indulged these questions. But yeah, it does this first, and puts that in more cookies, and then puts that in cookies. So that's the answer. All right. Any other questions before we stop for this time?
It's so funny
Oh.
that we don't know what it's gonna do, like somebody
Well,
wrote this program.
But there's like a rule, you know what I mean? Like the issue is like different programming languages that have roughly the same syntax
Yeah.
have different rules about what to do.
Somebody who wrote this should know ahead of time exactly what.
Oh, they know. I just don't know personally.
It's just interesting.
but these are weird edge cases. Like you probably never had to think about what a mathematical operator means in this much depth before, right?
Try not to, actually.
Yeah. So we're gonna,
Could you go back to your script?
Mhm.
What we're trying to do on like line
Thank you.
9?
Yep.
8, I think. I got,
The print. I got 3 more cookies.
yeah, why did you do the whole 3 thing instead of just typing out 3?
Oh, you could have.
Oh, I guess I could have. Yeah. I guess I was in like, if that. You know, I was probably thinking like I should have made a variable called like cookies to add or something like that and set that be equal to 3. Yeah, instead of use like 3 literally in the script, I
Okay,
just
so
did.
like doing that to integers isn't something we need to do.
If you don't need to use the integer afterwards, then yeah, you can just be the string.
Oh, yeah, you're right. I see what you're saying. Yes, there was no reason I couldn't have just put it in the string.
Okay.
I think my head was in like, if that were a variable, we'd have to do it that way, right? So if let's say if we do, if we say like added, let's actually do it this way, added cookies equals 3, and let's put this one after that line actually. So like this would be kind of a better way to express this anyway. So cookies equals cookies plus added cookies. And then like, let's see. That go, added cookies. All right. Now if I run that with Python. Oh, sorry. All that other stuff doesn't really matter. Let's start with less cookies just to make life easier. Let's do like 5 cookies. Fewer cookies, I should say. Actually, here, let's do one more thing. Oh, wait. What did I screw up? Can I save this? Where did it do all those cookies? I thought I did. Maybe I didn't. All right, let's try this one more time. Maybe I just didn't save it quick. Properly. All right, I just must have not hit save hard enough. Okay. So this works, right? I got 3 more cookies. Is what it says there, and that I got whatever many cookies lying. Of course, if we took the quotation marks like out like this,
Yeah.
what is that going to do?
We'll just say added cookies, more cookies.
Yeah, it's going to literally say I got added cookies, more cookies, right? Because now that's part of the English string. It's not part of the, so the difference is, right, like, 3 means 3 to both Python and your eyeballs, right? You know what I mean? Like the number 3 when you write it means the concept 3, but Python, like, in other words, it doesn't take a special way in Python to like express numbers. Like you know what? This is like a weird way to say it, right? But like 3 means the literal value 3 to Python. Whereas, added cookies, if it's part of the string, means like the text, words, added cookies. But if you have it like outside of a quoted string, it means, the value represented by that, right? Like I think we talked about that last time with like what quotation marks mean, right? Like,
Yeah.
the word dog doesn't mean a dog, right? But
Oh, so do those quotation marks mean like those are 2 separate strings surrounding?
yeah, those are just 3 things.
Oh,
That's a string, and then a
okay.
thing, and then a string. Yeah. But you could have like just 3 things that are all like not strings. There's nothing special. Like what it's doing basically implicitly. Okay, we gotta go. We gotta be done. But it's basically what it's doing there implicitly when you say to print something that's not text. Print knows to like convert the thing that isn't already text into a readable text version, right? Because that number 3 is not like written down in the computer somewhere in something that looks like a 3, right? It's represented as like 1-1 in binary or whatever. You know what I mean? So it's got to convert that into like the physical representation of the number 3. But print does that kind of implicitly with numbers and stuff. Like when you say print 5, or print some variable that holds the value 5, it puts like the character 5 on the screen. It doesn't like have to, you know what I mean? Like that's a conversion it has to do from a numeric value to the printed form of that numeric value, or the text form of that numeric value.
Mm-hmm.
You know what I mean? But it does that for you automatically.
Okay.
Now, what it wouldn't do, like in other words, what you can't do, although you can do this in stupid languages like JavaScript that sucks, like what you can't do is say like, so you can say like something like that, right? And it'll say cookies 5. What you can't do is say, oops, cookie string equals cookies. I don't think you can. Oh, wait, you totally can. All right. Oh, no, okay. I'm sort of right. It doesn't just make a string that says cookies : 5 or cookies space 5. It actually does something entirely different, which is make a list. But we haven't talked about lists yet, and that's outside the scope of this lesson. So the short answer is like that thing that print does is like a special thing that it does to convert non-text stuff to text, so it can print it out for you. That's not like, well, we'll talk about that more later. All right, we got to go. No more deep questions. Thanks, guys. Sorry if that got like off the